Hello, Assalamualaikum. My name is Muhammad Adam. I'm from BEKGS1. Okay, I want to introduce you today about my final year project, that is sleep stage classification using time frequency distribution of bioradiolocation. Okay, my research motivation is first, list a research about sleep stage according to time frequency distribution. Okay, as we all know, sleep is a natural state of rest during which eyes are closed and body become unconscious. Okay, for a normal people, it will reach 3 stages of sleep. Okay, this is normal people. Okay, not all people can reach normal sleep stage and turn out to having a sleeping disorder. Okay, from the research, we know that the 38% of person live in urban area got insomnia, and 12% of the others got chronic insomnia. So this problem need a future solution and study to overcome this disease. Okay, at the end, this research will reveal sleep stage that can be produced from the time frequency distribution signal. Can know whether the person is having a normal sleep or not. Okay, let's jump to a next slide. Problem statement. Number 1, the condition of sleep pattern is different based on its frequency stage. Bioradiolocation signal are low frequency non-stationary signal. Time domain and frequency domain based technique are not suitable for this sleep stage classification due to low frequency signal, and using time domain is hard to determine sleep stage condition. Okay, next is objective of our research. Number 1, to classify sleep stage classification using time frequency distribution. Number 2, to compare sleep stages that consist of wakefulness, REM, light sleep and deep sleep based on time, frequency and time frequency distribution. Number 3, to analyze 3 sleep stages using bioradiolocation data based on time frequency distribution. Okay, next. Literature review. What is bioradiolocation? Bioradiolocation is non-contact fall detection method which remote detection of biological object and registration of limb and organ motion using radar, which means non-contact instrument that used in this experiment. And the method of this experiment is to detect the movement only in during sleep period. Okay, for future extraction, the aim is to reduce the number of future dataset into more manageable of features. So we can conclude for advantage and disadvantage. For time domain, it has a low noise environment and lower computational complexity, but it cannot localize bioradiolocation signal to its state. For frequency domain, it can reducing the interference and good localization of the signal. So we can know frequency domain for each state for the sleep stages. But the disadvantage is it has a high noise environment. For time frequency domain, it can overcome the limitation of time domain and frequency domain. But the disadvantage of the time frequency domain is high dimensionality and high resolution of feature vector. Sleep stage. The 2 sleep group come from an REM and REM. For the first stage is light sleep, N1 and N2. This stage like we just start our sleep, or like drowsiness, or another one like micro sleep. This is the first stage of light sleep. First stage sleep is not longer. The composition first stage is only 1 to 5% of our sleep. Then we will go to the second stage. Second stage is the stable stage. That's why it is called a stable sleep. It acquires 45 to 55% from our sleep time. It is the long duration sleep. In this stage, our body refresh and rest. Core temperature drop down a bit. Blood pressure will slow a bit, and also then the normal pressure like other also such as vital sign, heartbeat, pulse rate will be slow. Okay, next is a signal classifier. There are 3 types of classifier that we use for this classification. First one is support vector machine, SVM. Number 2, K nearest neighbor, KNN. And number 3 is fuzzy. The advantage of using SVM is it works well, very well when clear margin of separation between clauses. But the disadvantage is does not perform well when dataset has more noises. For KNN, it's very simple implementation but is sensitive to noise and missing data. And number 3 is fuzzy. Advantage is can work well with noise but not always accurate prediction because it's based on assumption. Methodology. The research consists of 3 stages, which are signal pre-processing, signal processing, and signal classification. At the left side, from the signal pre-processing, we will load the dataset into MATLAB. Consists of 16 signal with one subject. Okay, and then we extract the data, and then we go to the signal processing, find the time frequency distribution. From the time frequency distribution, we will get the gain average VRMS from the bioradial location signal. After that, signal classification. We will classify the VRMS data into the classifier and compare the result database on signal. And lastly, we will determine the accuracy of the data based on the sleep stage level. For the result, we use bioradiolocation data simulation using MATLAB. We have 32 subjects. In one subject, we have 16 signal. We use time domain graph, and then the 16 signal will combine in one single graph. For the expected outcome for final year project 2, I hope that I can make a comparison of sleep stage between the different domain or parameter, and lastly can classify sleep stage using time frequency domain as well as my objective. Okay, thank you and Assalamualaikum.